Question 3 of our dream paper 1 was all about nature of roots, which I'm not joking, not sarcastically. This is actually one of my favorite parts of algebra that we do. It's a very theory heavy part, and you need to know your theory and you need to know your classifications of numbers to be able to understand this. But I think once you have that part, if you've sorted it out in grade 9 when you were supposed to, then it should have been nice. And generally, especially the first two questions was answered really nice in the exam. Firstly, 3.1 is asking us without solving the equation, meaning you can't go find the roots and then describe them for me. You need to describe the nature of roots. So that's where you have to bring in your delta, which we should know delta is b squared minus 4ac. It's the part that's underneath the root, the nature of roots, underneath the root in your quadratic formula, right? And then you go substitute. B is -1, A is 3, and C is 4. And then you should be getting -47. Because this is negative, and you have to think of it also as when you have a negative underneath the root, that's non-real, right? So your roots are non-real, and you stop there, okay? Because there's no classifications underneath non-real. Could have also said imaginary, that's fine. We just generally don't use that word in high school, unless you do like AdMaths or whatever. Then again, this question, you go find your delta. Your B this time was 2. 1 was your A, and -3. Now, a lot of us were heroes in this paper. And then you told me here, minus. But there's a negative times a negative, so this is +12. Okay, a lot of you lost unnecessary marks here. And then you should be getting 16. And then 16, okay, so it is real because it's positive. That's the first thing. Then you need to say, is it rational or irrational? This is a perfect square, so it's rational. And then you have to say, is it equal or unequal? It's not 0, so it's unequal. Remember, if it's non-real, you only write one thing. If it's real, you have 3 categories. Then there's something given to you, an equation of p, and they ask you for which values of x will p be. Undefined. Now, undefined is dividing by 0. Okay, so you have to go look at your denominators. Okay, those are denominators 3. That can't be undefined, so it has to be where x plus 2 is 0. So in other words, -2. You don't say not -2 because they're asking you where is it undefined. So you have to say where x is equal to -2. Then where is it non-real? Okay, dividing by 0 is not non-real. It's undefined is separate. Non-real has to do with a negative under a root. Okay, so 5 can't be negative. So it's basically where this is negative. Where x plus 2 is negative, negative is less than 0. So it's where x is less than -2. And then where is this equation real? So of course real is where you have 0 or a positive underneath a root. So it would be the opposite of this, but just watch out. It can't be equal to 0. It can't be equal to because then you have undefined, right? So it is where x plus 2 is greater than 0, not greater or equal to, though that is usually what the real part is. And then x is greater than -2. Then the roots of a quadratic equation are there. So they gave you the quadratic formula. The roots, they're telling you those are the 2 x-intercepts. For which value of n will the roots be equal? Okay, so equal roots you need to know is if there's no variation happening, and there's the variation, okay? That's the part that varies. So in other words, where this is equal to 0. So where your delta, which is 25 minus n squared, is equal to 0. And then you can do your dots. It's 5 and 5, n and n, plus and minus. So where n is -5 or n is +5. Those are your 2 answers. Of course, alternatively, you could have gone for where n squared is equal to 25, therefore where n is ±5. That would have also been fine. And then our last question, show that the roots of this equation Okay, so they haven't given it to you as roots yet. You still have to do the delta part. Show that the roots are rational for all rational values of p. Rational. So they're asking you to prove that's a perfect square. So firstly, go write this so it's in standard form. So you have x squared plus px plus p minus 1. Then your a is 1, there's your b, and this whole 2 terms is your c. So when you go substitute into delta, remember that. So we have p squared minus 4 gets times with p and with negative 1. So it's negative 4p plus 4. And then when you go factorize this, you'll see it's 2 of the same brackets. This is actually p minus 2 squared. Okay, then once you have written it this way, you say therefore your delta, your discriminant, is a perfect square. And then because it is a perfect square, the roots are rational for all rational values of p, of course. Okay, this is very important. You cannot just stop there. You have to make a conclusion. You have to say the roots are rational because it's a perfect square. It doesn't have to be underneath one another like that. You could have said, therefore the roots are rational because the delta is a perfect square.